Hello everyone. This video provides an animated demonstration of Lab Activity 8, which investigates Newton's second law of motion. The purpose of this experiment is to verify Newton's second law of motion for a glider that is accelerated along an air track, as shown below in Figure 1 that was taken from the lab instructions. The following schematic will show the air track in action. When the air blower is switched on, it pumps air through tiny holes along the air track. This creates a cushion of air under the glider that allows it to move almost frictionless along the air track. The hanging mass will then fall freely under the influence of gravity, pulling on the glider by means of the cord that connects them. A sonar emitter and receiver sends out sound waves that are reflected by the glider as it moves along the air track. The glider's position, velocity, and acceleration are determined at regular time intervals by using the time it takes the emitted sound to return to the receiver. Switching on the air blower, we see the glider and the hanging mass begin to accelerate. The emitted sound waves are shown reflected by the glider. Reaching the end of the air track, the glider makes contact with a spring that sends the glider back in the opposite direction, pulling the hanging mass up with it. Under ideal circumstances, the glider returns to its initial starting point after every rebound. However, in the actual experiment, various forms of friction such as air friction, as well as the friction in the pulley wheel, can cause the system to lose energy such that the glider eventually comes to a complete stop at the end of the air track. Having seen the air track in action, we will now see how the glider's position and velocity is recorded as a function of time. Switching on the air blower, the glider begins to accelerate as before. On the right-hand side, we now see the corresponding plots of the glider's position and velocity being traced out in real time. Notice how the plot of position takes on a parabolic shape as the glider rebounds back to its starting position, stops, and then accelerates back down the air track. Similarly, notice how the glider's velocity switches from positive to negative when it rebounds, and how the velocity becomes zero when the glider reaches its starting point. In the Excel spreadsheet that you have been provided, there are 3 separate worksheets or trials that contain values for the glider's position, velocity, and acceleration. Note that each trial uses a different mass for the glider and the hanging mass. If you plot the entire position and velocity data for one of the trials, they will appear like the plot shown in this slide, in which the uniform acceleration experienced by the glider abruptly ends every time it hits the spring at the end of the air track. For your analysis, you want data corresponding to just the uniform acceleration, which means selecting the data over a time interval during which the position data is parabolic and the velocity data is linear, just like what is being shown in this slide. Do this for each of the 3 trials of data corresponding to the different masses. The data that you have selected will then be used to conduct the analysis as discussed in the data analysis section of the lab instructions. This then concludes the demonstration for Lab Activity 8. I hope this video has provided you with enough information to get you started on the lab. As always, please send a MEO if you have any questions, and thank you.